You're tuned in for some references, pointers, and arrays today. Stand by. This video is about to start. This is the Savage Scientist Ed right here, and I'm writing code in a police car. Yo, you remember the last video? I said we about to have a quiz. This is our quiz. Do you know the difference between parameters and arguments? The answer is parameters are the values we supply to our function when we're defining the body of the function. Arguments are the values we use whenever we're doing a function call. If that quiz gave you a little trouble, then I suggest you go back to day 10 and take a look at functions over. And if you ace that quiz, then I think it's time for you to move on to today's topic. Today we're going to talk about references, pointers, and arrays. Here's our list of topics for this video. You already know to jump ahead to whatever topic you want to hear. So I think now it's about time for us to talk about exactly what is a reference. So let's say we have integer x and we have int reference xr. This is x and it has a value 63. When we create XR, it's going to refer to our integer value x. So whatever we do to XR has the same effect on x. And that's basically what a reference is. So you're going to see this throughout this example. So just keep that in mind. And we're going to start our favorite compiler here, our favorite IDE, DevC++, at least for right now, because we're about to start switching over to Visual Studio Code soon. So get ready for that. So we start in DevC++. First thing we're going to do is create a new project. And we're going to name our project, which is a console application. We're going to name this console application ref, R-E-F, PTR for pointers, arrays, A-R-R-Y for array. Hit OK. And we're going to hit save on this one. And we're going to get rid of our main function arguments. And we're going to get rid of this. We're about to drop our user namespace std. And now, let's create our first value. Int x equals 98. And the second thing we're going to do is we're about to create an alias for 98 in the form of a reference. And now it's time for us to create our reference. Int reference. And this symbol means reference. This and symbol. XREF. And we're about to set our X reference to X. And that's it. So this is the most important line to understand. We just created an integer reference that holds a reference to the value X. So whatever we do to X reference, we're also doing it to X. And we're about to see an example right now. Let's print our values to the screen. So there we have it. So we print now X and X reference. Now let's compile it. We're seeing X is 98 and X reference is 98. So let's see what happened if we modify X reference. So as you can see here, we just added 30 to X reference. It changed in both X and X reference. So now we're about to take this same line and we're going to say X equals X plus XREF. So what do you think the value is going to be when we print x and xref this time. Let's see. So our value is 256 because we just basically doubled xref and x. And remember, xref just happened to become 98 plus 30. And that is 108 and 30, that is 128. 128 plus 128 is 256. So our references is just an alias for a value that's already existing. But they have some things you can't do with references, like you can't reassign a reference after it's been created. But one great thing you can do is you can have two references pointing to the same variable. I should have said two references referencing the same value, which is x. So our new reference, xref2, is on line 10. And now let's print out xref2 right along with our value x in our first reference so we could see how these values change. All right, so now let's hurry up and run our program. Here it is. X is 256, xref is 256, and xref2 is 256. Anything we do to any of these values is gonna all change respectively. Let's see what happens when we increment one of these references, which is, in this case, xref2. So in this example, we have two references pointing to the same value. And when we increased xref2, that also changed the value in x and xref1. And for consistency, let's move xref2 up to the declaration part where we declare all the rest of our variables and references. So there we go. Don't that look better? Now it's time to talk about pointers, one of the most powerful features of the C++ programming language. Let me show it to you in code. So this is how we declare an integer pointer. And now let's drop it down the line. And we just created us an integer value that we're going to be using throughout this example. Let's set x to 61. And let's move this pointers comment down to line 8. So now let's assign our pointer to one of these values. So let's set our x pointer to our variable x. And let's compile and see what's going to happen. So as you can see, we got a compile error. And the reason why is because we didn't use our address operator. It looks just like the reference operator, but in this case, we are talking about address of. So what we are doing is we are setting xptr to the address of x. So now let's print the value of our pointer using the cout statement. And I'm going to tell you ahead of time, we will not be printing the value 98. This is going to give us the address of xptr pointer. So in order for us to print the actual value or the data that's in our pointer, we're going to have to rely on another operator. The star operator is known as the dereference operator, and this is how we get the actual value stored at our pointer. Now it's really time to start playing with some power. Let's reassign our x pointer, this time to point to the address of variable y, as you can see on line 7. And let's copy this down to line 13. And we're going to print the value of the address of x pointer so we can see how it changes. And we're going to see how our dereferenced value changes. And now let's see what's going to happen when we compile it. All right, so now it's time for us to start taking a look at the results from this code. So first we're going to start off by looking at the fact that we assigned x pointer to the value x. And x has the address of this 0x78FE 14 da. So that's the memory address location. And let me draw that on the screen. So now, whenever we call our pointer with the dereference, we are actually looking at the value that's stored in the value x. So x and the pointer are both pointing to the same memory address that holds the value 98. So then on line 12, which is something that you can only do with pointers, not references, we are about to reassign our pointer to another value. So we are assigning it to the number, to the variable y here. So y has an address of this same 0x hexadecimal, yada, 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 and it ends with the number 10. And the data in that address is 61. So our two values now is x with 98 at the address 0x something something 14, and our y has the value 0x78 and ends with 10. So our pointer could be readdressed, and we use the dereferencing operator to get our value from the pointer, and we use our address to find the physical memory address, which is represented in hexadecimal here in C++. So hexadecimal is a 16 numbered, a base 16 numbering system with 16 unique values. Just like we use our decimal 10 base system, and like you can't have no more than 10 numbers before you start repeating. That's why the number 11 is 1, 1. So I'm gonna have a video on my channel explaining that, but I think it's time for us to move on to arrays. All right, so first of all, this is how you declare an array. We're gonna start off with our type, and then our name, and then we're gonna have these square brackets. Inside the square brackets will be an optional size of the array. And size is just a way of just saying how many elements we're gonna have in our array. And when we declare this array, we're gonna use the size of the array being the number. We could just go with 4, I'm guessing. There we go. So now let's point to all these elements. So there it is. Our size of the array is 4. This is using all those elements. So what an array does is point to a specific area in memory, and it's gonna declare a block of memory to hold 4 values. And remember, array counts start at 0. So the first element will be x of 0, or the element x0. So look here at line 8. This expression 2 times the value of x of 0 is 0. So when you see this, just know that that's 0. So that's why we're going to just put it in our array. So x of 0 is 0, and we got x of 1 with 32. And let's put our x of 2 here, 982, and x of 3, let me think of a value here, 8,298. So here's some optional one, this money. We're going to just throw a value that we know won't work. So I just want you to see what happens when you try to address a value outside of the bounds of our array. So we're about to experiment. Now let's start with this for loop to loop through the elements in our array on line 14. And the purpose of this line is to print all the values in our array. So you already know, if you try to run this program with this line 12 money looking like this, it's going to give you an error. So let's fix this issue. First, what we're going to do is just declare money to be an integer value. And we're going to set it to 92. And now, watch how beautifully our program runs. See that? And you might notice that 92 isn't printed out in our results. So we're about to go into our for loop and make it so instead of having 4 values, we're going to make it so it's going to print 5 values. Because remember, arrays start with 0. So if you include 0, that is a count of 5 elements, starting from line 9 to line 13. 5 elements. And now all 5 of our values just printed. So we covered a lot in this video. We just got done discussing arrays. Arrays is a big thing in C++, so we're going to talk about that more as you progress through this course. We also talked about pointers, which is just as big as arrays, which makes C++ such a powerful language. And references, they also have their part in the importance of C++. In tomorrow's video, we're going to talk about function pointers, and we're going to start seeing some of this stuff gradually throughout this course. So this is the Savage Scientist Ed. Till I make my next video, peace out.